Today's video is on operations with radical expressions, and we're going to add and subtract today. So one thing you'll be looking for is if you have common square roots, kind of like terms to combine or unlike terms, and is there a way to still combine them? All right, so adding radicals with like radical expressions. So if I have square root of 2 and another square root of 2, this problem is basically saying I have 5 square roots of 2 plus 7 square roots of 2. So how many square roots of 2 do I have? We just have to add the coefficients. 5 plus 7. I have 12 square roots of 2, and then done. But if I have a square root of 3 plus a square root of 5, they are not like radicals, so I cannot simplify them. There's nothing I can do with that expression. It is done. All right, well now let's look at this example. I've got the square root of 5 plus the square root of 20. They are not like radicals, so I can't add them. But the square root of 20 is not simplified. So let's think about this. Square root of 5, that is simplified. I can't do anything else with that. Plus, let's see, the square root of, can we break 20 up? I can break it up into 4 times 5, where 4 is a perfect square factor. So square root of 5 plus the square root of 4 times the square root of 5. So this is the square root of 5 plus 2 square roots of 5. So the first one, it's like 1 square roots of 5 plus 2 square roots of 5. Add the coefficients, so 3 square roots of 5. All right, so now I've got 4 square roots of 8 plus 3 square roots of 50. I do not have like terms, but I can simplify. Let's see, square root of 8 can simplify, and square root of 50 can simplify. So let's think about this. I've got the 4 out in front times 8 can be broken up into 4 times 2 because 4 is a perfect square, plus 3, the square root of, well, 50 can be broken up into 25 times 2. 25 is a perfect square. And then if I break that up, I've got 4 times the square root of 4 times the square root of 2. Well, the square root of 4 is 2, so 4 times 2 square root of 2, plus, okay, I've got 3, the square root of 25 is 5, and then square root of 2. Now let's see, I can multiply here and here. So 8 square roots of 2 plus 15 square roots of 2. Now I've got the common radical, so I can add 8 plus 15 is 23 square roots of 2. For this example, I want you to write it down and pause the video, try it on your own, and then come back and check your answers, and then we'll do one more problem all together. All right, so checking your answers. I broke this up into 49 and 2, this up into 16 and 2, split it up, square root here, and then 7 square roots of 2 minus 8 square roots of 2 is negative 1 square roots of 2. All right, here's our final example of this lesson. So I've got 3 this time, 3 square roots of 90. So how can we break 90 up into 2 factors? I'm going to do 9 and 10. Okay, plus 4 square root of 20. I can do 4 and 5. And then let's see, 162. I can do 81 and 2. All right, so 3 times the square root of 9 times the square root of 10, plus 4 times the square root of 4 times the square root of 5, plus the square root of 81 times the square root of 2. All right, so 3 times 3 square root of 10 plus 4 times 2 square root of 5 plus 9 square root of 2. Well, none of my radicals, when simplified, are alike. So all I can do is just kind of bring down. I've got 9 square root of 10 plus 8 square root of 5 plus 9 square root of 2. So they're all simplified, but none of them are like terms to combine. So we just have to keep them all separate, and that's as much as we can do. So there's your full lesson on adding and subtracting radical expressions. Good luck.